Hello, my dear students, and here is your very first practical class. At least I hope it will be more practical for you. And and in practical class, you need to demonstrate your skills obtained during theoretical class and to develop some skills above all. What is your very first task? Right now, you see file with, let's say, it's not explanation, it's task reminding, let it be. What is task number one? You will have photos of some airplanes, not this one. You will have individual task, practical individual, considering that there are more than 100 of students. It's difficult to make it completely individual, but at least you will have variants of tasks. In each task you have, in each variant, you have some photos of airplane of different classes and different design. And what I ask you to do, give characteristic of airplane, not much, literally about 10-15 words. And in these 10-15 words, it should be explained what is the purpose of airplane, considering what it looks like. I ask you first, try it on your own. Of course, you are all very smart, I trust, and you are able to find everything in internet and to read the information. But first, please try to make it on your own. The purpose of internet. The purpose of internet is to spoil our time. The purpose of the airplane. What is aerodynamical scheme of airplane? What is the wing configuration of airplane? Those no names. They are all given in lectures and books, and I hope I will not forget to show you where to have additional information in. What is landing gear, if it's visible? What is empennage? How do you think, what is the range of speed of this airplane? Engines? No, and another characteristic that you might notice, just characterize airplane according to this classification science that we have studied together. Task number 2. Task number 2 will be what I want you to do. Not like this, better like this. No, however you do it, also you'll have some photos of airplane, and immediately on this photo or under the photo, I trust you may do it in Paint, in other programs that you're working with. You may add either text immediately on the photo of airplane, or at least some arrows, some signs with figures, and explain those figures under the picture. I need you to identify the main aggregates of the airplane and flight controls, primary, secondary, high lift devices. And after this, I would like you to write some words about function of these aggregates and about the function of flight controls. No, that is like for the joke, certainly it's maybe not compulsory the student work. Maybe it's some lecturer who draw it like me immediately during the class, and that is why airplane looks so funny. That is quite clear. It's like more technically correct picture. Together with the pictures of airplane, you will see the picture of wing, like separately. So you will have some pictures of airplane and some pictures of wing. Wing will be the only for each variant. Practically all the photo looks very similar. They made in different on different airplanes. They made in different circumstances, but they are very similar. And what you will see as wing looks something like this, but real one. And on this real one, I propose you do the same. Show the names of flight controls. that you might identify what you see there. Show the names and please show their describe their functions. Not much also. Flap, increase lift, aileron, control roll, something like this. If you did it once, you don't need to repeat it hundreds of times for each photo. Just under the each photo, please, under the each photo or on each photo, please, the legend, so-called explanation, names, give the names to the aggregates, to the flight controls, and under the wing, the flight controls, and somewhere one abstract where it's explained what they are for. No, how it will be convenient to you, up to you. What is the price for these tasks? You see, I left task number 1, 5 point, task number 2, 5 point, and it's very first class I said for practical classes for you. Next, you will have more. I'm promise not to overload you much, but next task will be a bit more complex for you, and next task will be more expensive, let's say, in points. This one, as for me, it's very simple. And in order you may do it next with this, literally with this. Right now we will do some short journey into structures of airplanes, but partly you have already seen those things. We will see some airplanes and try to understand together what are different aggregates and flight controls that we see in a photo. Whatever you heard from me, let me to show you. I checked on purpose. Where is it? In your conversation with me. No, in computer it's not visible normally. It does not show. I have no idea why. It does not show me the front page of the book. The book that I have downloaded a week ago. It's about the movies. Technology roadmap. Introduction, key of the. Oh, here is. Pay attention. That is book, textbook of HAI about aircraft design. It's need for first years, of course. It's not for first years, of course. Yes, for first years it's a bit more complicated because it's for students of third year of our specialty, of our major. As far as I know, it's for third years. But in this book, it's possible to find things at the beginning. I have opened it already. Here is the content of the book, you see. Quality, not so ideal, of course, like quality of FAA books. Here is short explanations you might find about the different airplane configurations, about the configurations of wing, landing gears, those things that we have studied in lectures about airplane design. That one, it's very interesting, but it will be one of subject of our practical class number 2. The things that you need to do. And about aircraft structures, don't pay much attention to formulas and other things. Maybe it's the subject for studying in the higher courses, let's say, in higher years. But at least some illustrations, at least some short reminding about if you prefer to see it in a paper, not listening in lectures once again and once again, you might find it here. And together with pictures. Of course, as I've already said, you more colorful pictures for people of your generation, they are more appropriate, more pleasant, let's say, more convenient to understand. No, at least you have seen where you might check some information. It's a little bit more than I explained it, because it's, as I said, it's not for first years. Uh, I do not propose, again, study it by heart, but if you need it, find please somewhere, no, at least scroll it and find pictures that are familiar to you or that related to the matter you need to find, and do read information like around the picture, and in this case I trust will have significant help for you. But for instance, these elements of joining we do not study at all, because it's like too early for students of first year. This discipline is more survey discipline, surveying discipline, something like this. Так, once again, what you need to do for different, on different photos of airplane, no, in different photos or on different photos immediately of airplane, you need to give your provision what this airplane is. If you'd like, of course, next you may check in internet, you might find it by photo and what is it really, and read about everything. But I propose you to use your brains above the all. Characterize airplane. What do you see? And in another group of photo that you have, you need to explain details, let's say, names of aggregates and their functions for whole photo of airplane and for the photo of the wing in airplane. I think it's not difficult. It's not take too much time, I hope. And let's continue what I said. Let's try to watch. Oh, here is airplanes and together and give characteristics to them. Now, what we need to pay attention for first. Look, the only cockpit here, no windows, no anything at all. Of course, in a photo we can't mostly we can't assess sizes. No, here is we have people near the plane, and we understand that this plane is rather big. And near those airplanes we have no people, not clear what is the size, but certainly we see where the cockpit. And due to this, we understand that this airplane is rather short, little, and this airplane it's more big in size. And moreover, illuminators, windows for passengers are visible. So purpose, certainly, here is not for people, it's military airplane, and here is the passenger airplane. By shapes of this airplane, if we compare this airplane with such a primitive scheme and shapes of noses, of wings, and so on, what we should understand, these airplanes are supersonic. I'm not asking you to give speeds of them. No, something like subsonic, supersonic. It's very simple, actually. By their general appearance, it's easy understandable. What about the balancing scheme? No, here it's written. Actually, all the airplanes here, they are of canard scheme. It's quite clear. But they are different in their empennage scheme, as you might see. Canard scheme, empennage tail unit fin. This is so-called double fin, V fin. Certainly, we have two fins, and they are a bit deviated from the vertical surface. And here, quite normal, conventional fin. But what is interesting, in photo number 3, ideally visible, this canard scheme use not stabilizer with elevators, but stabilator. Stabilator is the stabilizer which combine functions of stabilizer and elevator both. By the word, what is it? What are these boxes that under the belly of the airplane and close it with some red no, shields, let's call it. They are for protecting, in order to prevent at the airfield to prevent the interference, let's say, in the engine of whatsoever, of another person, or to forget some tool, bird that may do something inside this intake holes. They are intake channels for engine. And do pay attention. There are two intake channels. There are two nozzles of the engine, and it means that you may do no like provision. Now you may say that there are two engines, and both of them are inside of the fuselage. Intake hole is under the belly, engine somewhere here, and it's finished with the nozzle. Do pay attention to interesting thing here. Nozzle looks in different sides. That will be the story of one of another classes. Well, and that one is supersonic passenger airplane by its appearance. No, of course, you already recognize it. I already said you sometimes it's Tupolev 144 that been in exploitation, in operating in Soviet Union in 60 years, and next it was out of operation because it's too much expensive, too much noisy, technical problems may occur with this airplane, no, so on. But European Concorde has continued exploitation whatsoever. This Aerospace and BAE together have designed this. No, France, Aerospace, it was not only a France company, it was even more, it's include Italy, Spain, so on. And what this airplane, what is interesting in this airplane? No, pay attention. It's also of canard scheme, and it's not just even canard scheme. It's so-called convertible scheme. No, in this photo we can't understand it, but I have already shown you what it looks in flight. Don't be surprised that I'm lazy to switch the keyboard. In flight, look straight, completely straight, nose not deviated, and do compare. No, what here is visible in two photos. Difference significantly visible, and here is you see straight nose. Four engines by the word are visible. No, intake holes also of rectangular shape, and they are visible in that photo. There are four intake holes, and it means you have four engines. No, they are under the airplane. Intake holes you see here under the wing, and engines they are practically behind of passenger cockpit or cockpit cabin, behind of passenger cabin, and they are under the airplane, and nozzles are not far from the trailing edge of this airplane. And what is visible, well visible, I said here, that airplane is straight in flight, and in airfield configuration, you see the nose moved down. What it for? It's to provide visibility of the airfield while takeoff and landing for pilots. No, and also it's change curvature of the fuselage during the somehow help, let's say, to work with lift. Interesting photo we see here, this one. There are two supersonic passengers airplanes. Second one, it's not much visible, but you see the differences of them. A little bit different shape of the wing, little bit, not much. And you see differences and similarities. Sharp shapes, very sharp. It means supersonic. Our is with retractable fuselage with of convertible scheme, and that one it's European Concorde. It's maybe it's tailless scheme. I should check, of course, but I think it's tailless so-called scheme when it's practically has no stabilizer or some other balancing devices. It has something like mustaches on the front portion on the fore fuselage, but not visible in this photo. But it's not normal stabilizer, of course. No, maybe these mustaches may be considered like canard scheme. one is, no, the front is Soviet airplane, supersonic passenger, and on the back, size it's the same practically, just they are in different distance from the photographer. Let's continue this. When we start talking about designs of airplane, about their history and so on, it's endless story actually, and it's like pulling inside, and it's possible to forget everything watching these photos, and in some cases surprising and terrifying even. What is it? Why they do it like this? Let's continue. Now, yes, I opened it in this photo. We have already seen it. There are three airplanes in front of us, not four, but three. Four photos, bottom photos, they show the same airplane. What this airplane, what we might say about those airplane? First, the bottom one, great visible. It's flying boat. Literally, it looks like a boat. It's flying boat. Yes, but if it's a boat, why it has landing gear? Because it's amphibious plane. And I'm already paid your attention that amphibious planes, they are usually, typically, they are of high wing scheme. That is by the word to your characteristic of the airplane for each airplane. Look, conventional scheme, balancing scheme for each of them. What next? Low wing. Here is high wing, and all of them are of monoplane type. So it's conventional scheme, monoplane, high wing, and low wing here. What about tails? Uh, Look, here is you have so-called medium stabilizer. It's not on the fuselage and not at the top. And here you have so-called low stabilizer. No, it's quite conventional decision. And in this one, it's not so good visible. It's in these photos. In this photo, it's quite disappeared. Look at all. It's very interesting decision of tail unit group of empennage. Stabilizer of gate type. It's like litera pi. It's in English it's called gate. And this gate type stabilizer, it's not even really completely gate, because on the photo visible that fins are a little bit deviated from vertical surface. So V type and the stabilizer on the top. No, control surfaces are not visible, but in this airplane. But what is certainly visible? Here is floats, so called, to support its takeoff and landing on the water when it's necessary. And what about the speed? How we may decide something about speed of these airplanes? Shapes, no, rather sharp, let's say. This one, that one, no, rather similar noses. How to decide what is it? Also, so-called relative thickness of profile may help us. Where we have more sharp profile, more thin and more sharp at the leading edge, it's supersonic airplane. Where we have more thick and rounded, so-called like airfoil at the leading edge, it's subsonic. No, in this photo, it's somehow visible that this subsonic, but no, for you, it should certainly visible that it's subsonic by another side. What about this? No, rather sharp nose. Circular profile, yes, maybe circular profile is here. That one certainly it's supersonic by their shapes. But what is about wing? Wing is here practically straight. No, maybe it's tapered, but not much visible in this photo. In this case, we see a so-called swept wing, normal sweptness. And in this case, swept, but you might see the tracks of wing rotations. so-called pivot is here, and this pivot is responsible for rotation the wing during the flight. It's variable sweepness, variably swept wing. And what it for? Remind you that at supersonic configuration, when big sweepness or even triangular delta wing, not triangular, but delta wing is preferable, but supersonic speed will happen in some minutes of flight, not right now, immediately at the moment of takeoff and or at the moment of landing. So at the takeoff and landing, it's more preferable to have straight wing with low sweepness to reduce drag. And that is why these variable sweepness decisions, they used for some airplanes, not for passenger airplanes, of course. Usually it comes about the military airplanes, you understand. Um, because these moments of change, no, as I should say that those airplanes where you have this any tricks like this with changing of geometry during the flight, whatever they are, even flaps, for instance, these additional functions, they resulted in increasing the weight of the airplane. Because to rotate those things, no, above all, this place you need to make more heavy, it's more thick, more massive, such a place. It's additional material. Additional material, it means additional weight. Additional weight means additional fuel for flight. Dreadful life, you do remember. It's like resulted in the motion by circle with increasing the weight. And additional problems that besides of heavy weight, wherever we have changing of geometry during the flight, it's some problem might have been a problem with stability of the airplane at this moment. So airplane a little bit unstable on this mode in this moment when it change geometry. And of course, for passenger airplane, flaps, all these highly devices, slats, whatever, they are necessary on one hand, but and we are paying with extra weight for this additional changing of geometry for these high-lift devices. We are paying with extra weight, and this extra weight next. I hope you do remember it already because I repeated it sometimes. This extra weight you are carrying during some tens of years, and it means that extra weight it's resulted in hundreds, thousands of extra weight of fuel that you spend for this extra weight of structural design of your airplane. But when it comes about passenger airplane, you are not ready, no, like you're not ready to agree with the fact that you will pay more, yes, for your flights. And flaps, ailerons, primary flight controls, secondary flight controls, they are necessary. We will use them. What is not necessary significantly for cruise flight, for instance, like variable geometry. In this case, you are not ready to pay for this, and passenger airplane usually have no such significant changes of geometry. But military airplanes, they are out of consideration of money. They are at the first point they have their technical performances. And it's not passenger who pay for this airplane. Usually it comes about society in a whole, of course, quite clear. But it's usually government paying for this airplane and for operating, for manufacturing of this airplane, and military airplanes, not economical considerations at the first place, but maneuverability, technical performances, like their purpose on the first place by any price. When, in contrary, the civil airplanes, economical efficiency usually at the first place. Well, let's continue our characteristics of airplane. It's another, not the amphibious plane that we have seen, but it's very similar story with empennage. You see, it has two fins and stabilizer of gate type, but look at this. This one has the only fuselage, this hydroplane, this flying boat, and that one, yes, it has fuselage, but fuselage is very short. It's only seems like it's only for carrying the cockpit. Ah, I forgot to mention one more thing. For carrying the cockpit and for carrying the engine. There, somewhere there, two intake holes from one side and another side. Actually, I think it comes about the only engine, but uh, the only engine may have two intakes on sides of the airplane. It may happen. We not see the engine right now. It's somewhere hidden. And what is with this fuselage? Fuselage of twin beam types. It's not normal fuselage here. It's a beam, so called, because fuselage is some aggregate of the aircraft where which may accommodate cargo, people, crew, and so on. So this is a fuselage, and there are two beams, and this fuselage is of twin beam type. What I forget to say here, how to understand what is the speed of these airplanes, which is faster, which is more slower. No, that is certainly supersonic. Look, even intake holes, they are intake channels, intake devices. They are of rectangular shape. They are placed on sides of the airplane, and then it's finished here with two engines nozzles. What about this one? How to compare? Geometry of nose rather similar, sharp enough here there, but type of engine completely different. And I hope you do remember what I've been talking about, the field of operating of that or another engine. Here is certainly jet engine, no props. No, you do remember that only two variants we have. What may propel us through the air? Either it will be a prop or it will be jet stream. In this case, certainly it comes about jet stream. Jet stream, prop, what does it mean for us? It means that this airplane is more speedy. Maybe it's near transonic speed. It's like high subsonic speeds. And this airplane is much more slow. Uh, right now, it's not possible to we're not sure what this inside engine. I think it's not jet engine. It's not turbo gas engine. I think here is a piston engine with prop, considering proportion of this airplane. But whatsoever prop, it's already a signal to you. This airplane fly with little speed, comparatively little speed. No, in all the cases, it comes about air-breathing engines, and it means that they are flying somewhere in on heights that not higher than 10, 12 kilometers, and certainly this one may fly higher because of jet engine. You do remember the areas of operating of engines, piston engine, around 5, 6 kilometers near the ground, and with a speed up to 0.5 Mach number, and turboprop may be used. Turboprop, I mean turbogas engine with prop, may be used on higher heights and on greater speeds, but also not much significant, around 0.7, 0.8 Mach number. And turbojet engine practically has no limitations. How to understand whether it's turbojet or it's turbofan? Turbofan will be much more fatter. This one, it's rather slim, elegant engine. That is turbojet engine. Turbofan will have here additional diameter, let's say. It will looks more barrel-like. Let's continue, people. What about this airplane? Again, type of airplane is flying boat, but it's not clean flying boat. You might see it's with landing gear. It means it's not just flying boat, it's amphibious airplane. Do pay attention. Conventional scheme, but in this conventional scheme, there is an interesting peculiarity, not much visible on the top photo, but visible at the bottom one. Stabilizer, high stabilizer by the word, it's higher than the fuselage. It's not inside of fuselage, but it's not T-shaped stabilizer. It's higher than fuselage, but not much. And do pay attention, fins. Now fins are on side of stabilizer. In contrary to what we have here, one stabilizer surface joined to two fins, to the top of two fins. Here is in contrary, fins are on the tips of stabilizer. Next, engines. Engines again with prop, and to pay attention, maybe here we already not with piston engines. Maybe it's necessary to check. I'm not insist. No, I think it's turbogas engine, turboprop, so called, and I do it on purpose. I don't know. I don't know. It's necessary to check because we have agreed that you need to characterize airplane by features that you see, that what you notice. Let's say, what is the purpose of this airplane? No, besides its flying boat, how do you think? Is it purposed for transportation of people, or it's for, I don't know, only for cargo, or it's maybe used like reconnaissance, maybe used like whatsoever, even as bomber, for instance. How to understand it? If we see no any additional elements like illuminators, passenger doors, passenger, it's not compulsory passengers. Passengers may be paratroopers, for instance. But there is no any feature like this here. And what is this airplane? No, look. Oh, it's even link I left for myself. If it's work. Are you working? Not much. Not funny. Will you work? Okay. If you're not working, let's use this. Harbin. We need to use Harbin. Да, by the names that given under the... Что ты делаешь? Under the name was given under the photo. It was that one. It's submarine. It's submarine fighter, let's say. This airplane is the охотник, the catcher of submarine. Here is, look. English. It's your airplane, Chinese airplane. Yep. And water bomb type 5. It's really like submarine bomber, you see. This one. And of course, no, not on this resource, but I trust you may a lot of another resources to read. Of course, it's understandable that it is patrolling airplane, checking the territory, let's say, and in case of some problem, I trust it's possible for this airplane to use some weapon against the submarine. But its function is to patrol the territory, watching that no enemies. Так, is it possible to close exactly this one? No, I have opened it already too much files in preparing to class, and that is result. I can't find the. I need to close everything in order to understand where that link was. Oh, it's tried. Oh, slowly, lazy, but tried at least. Okay, let's continue. This one. What do we see now? Again, we see a couple of. We haven't finished characterizing of this airplane. Wing, high wing, engines, turboprops, I trust. And certainly it's subsonic. No, quite clear. There is no need in patrolling on supersonic speed. Nothing will be notable in this speed. And here is couple of one no the same type practically like the flying boats, but at the bottom you see Beriev airplane. By the word Beriev Kabe was notable, was known especially for their flying boats and amphibious planes. But here is amphibious planes once again. Why? Because it's able to land both on the water and on the airfield. Uh, in case of your airplane or in case of Chinese airplane, what in this photo, it's why I place it here because of this fuselage, what this longitudinal fuselage to show you during classes what it looks like in real, this flying boat fuselage along the fuselage axis with sharp changing here of the in the middle approximately or into thirds, sharp changing of the shape you see. And in this airplane, in a photo at least, it's not visible that it's really this type of fuselage, neither in front nor in, no, not much visible. It's visible, but not much visible. Here is this changing of shape, significant, typical. But what is common for both of these airplanes? This one floats under the wing. This one, you see, they are like screaming about I'm flying boat. I'm airplane opposite to land and take off from water. And similar thing, but not visible any floats here under the wing because it's very old actually structure. It's between First and Second World War, at the beginning of age of big airplanes at all. And what do we see? Certainly, it's passenger airplane. It's not military. Look, the line of illuminators. The same, no, all the typical features of hydroplanes, of flying boats in three photos are good visible. High wing. Engine is as high as possible. No, in Chinese airplane, it's immediately in the wing, or no, in front of the wing. The engine itself in front of the wing. We may say that it's in the wing. Look, in Beriev airplane, it's over, not even wing, but it's over the fuselage. Pylons not visible. It's necessary to check whether they joined these pylons to fuselage or to the wing in another photo. But here is we see different types of engine. I think turboprop, I think piston engines, and I think turbojet. Stabilizers, already said here, look, rather high, but not T-shaped. And here it's already T-shaped. What for? To protect no, control surfaces, there, elevators, for instance, from water. Why engines are so high? Once again, to protect them from water, protect them from sucking of water during takeoff and landing, or occasional drops of water inside of engine because it's will be resulted in sort of explosion there in engine, no micro explosion, but whatsoever. And when it comes about piston engine with non-continuous combustion, it's not so not so catastrophic, let's say. But in case some interruption of combustion in combustion burning of fuel in jet engine, in combustion chamber of jet engine, it's the sort of disaster. It's so-called pumpage of engine, and it's maybe resulted with the whole crash of airplane. What is also interesting in this photo, take a look. There is so-called tractor scheme when airplane has props directed front to the engine, you see. And here is even not tractor or pushing scheme, here is combination. Look, it has 6 engines, and these 6 engines, either they need to have much more longer diameters of these props, or such a trick that they have used. You see, it has props in front of engine on and on back side of engine. So it has 6 engines but 12 props, this airplane. No, once again, it's German airplane of 20th years, 20th, 30th year of 20th century. It's Dornier airplane, Dornier X. Next one, what's this? This is this disaster. Actually, it's monster. It's airplane boomer. You see, it has no. It's not even visible the where the cockpit here. What do we see? We see extremely short wing, swept, but it's insignificant. Like little chicken without wings or any child of bird. Practically no wings. They're extremely insufficient. Look, the fins here are greater in size, seems like, by area, or equal in size to the wing. How can it be? It's so-called blended body or carrying fuselage. Its whole airplane consists from fuselage, practically. And such airplane certainly is a bomber, and such airplane is with 4 engines hidden either inside of fuselage or under the fuselage. No, that one is not real. It's a concept. Now it's already realized in the real one. In some years, no, it comes about 10 years maybe already. And now this airplane exists. Sorry, will not try to show you, but it's already exists. Once again, what this airplane is about? How do you think it's supersonic or subsonic? Some seconds you to think. My answer is, I guess it's subsonic, considering its non-sharp shapes here. I think, but I'm not an expert completely. No, it's better to check, of course, my words. And that one, in my opinion, is subsonic. It's a bomber, and it's so-called front bomber. It's not for far distances, I would say. And its primary task, of course, it's to carry heavy cargo, weapons, bombs. Bombs, maybe some cruise missiles, something like this, maybe. These beautiful structures. Just to see variants of possible structures. No, let's see first this twin fuselage. In this case, there are 2 normal twin fuselage airplane. And what it has monoplane. Look at the empennage. Visible very well that it has 2 fins, but stabilizer half here is present, inner half is absent. And quite the same will be on this fuselage. One half is present and another half is absent. Interesting decision. Next, engine. Engine of must be piston type, and it has a prop here, you see. And for the, no, like to characterize the range of speeds, that one, it's certainly for higher speeds than this one. It has more blunt nose, this middle one with blunt nose, with respect to what do you see here. And here is a retractable landing gear. Landing gear in flight is absent, and this one is, look, it has struts, non-retractable landing gear, which create additional drag in the flight. Quite clear that this one with low range of speed with respect to the bottom airplane. And pay attention to those structures, their general appearance. Yes, they are monoplanes, but all of them are monoplanes. That one, low wing, you see, it's under the fuselage. This half of wing, center wing, and another half of the wing. That one is strutted monoplane. This one is cantilever monoplane, and this one is strutted monoplane because it has struts from sides. And it's high wing, it's at the top of the fuselage. And that one is clean, and the most typical, by the word, for military airplanes, it's so-called mid-wing, because it's placed inside of the fuselage, in the middle. And how many fins it has? One, two, three fins. Where stabilizer? Do you see stabilizer? I am not. How provide stability of this airplane? Not sure. And certainly, uh, it's not compulsory the real one. It's maybe someone concept, let's say. But certainly it somehow should be provided. For instance, maybe there are some additional devices at the trailing edge of the wing, which maybe, or this one somehow may be used for stabilization of the flight, but certainly somehow it's necessary to provide stability in this airplane. Even visually, it looks like it's not much stable, but the lack of stability resulted in the higher maneuverability. So when it comes about passenger airplane, we are much, and cargo airplane, we are much concerned about stability, safety of flight. When it comes about the military airplanes, we are more concerned with their maneuverability for their flight performances, which help to survive in the no, in the battle, in the air battle. How it's called? Engage, да. Air engage, like this. And let's continue. Now here you see two fins, middle stabilizer, certainly in the middle of the fuselage. Or you may say it low stabilizer because it's rather low with respect to another surfaces. No, we get used to see fin, and in the middle of fin it will be mid stabilizer. So here better to say low stabilizer because it's immediately on the fuselage. No, that is the real one. That is the real one. Above the wall, what is it? We see biplane. It's Polycarpov E 190. E, it means in our language, истребитель, fighter. It was a fighter of Polycarpov, and at all these Polycarpov airplanes in 30th, 40th year of previous century, it was a lot of them, and they were well known, and mostly they were either fighters or front bombers, might be. No, mostly fighters. So what about its characteristic? Look, biplane, strutted biplane. No, there are a couple of wire braces here also, but mostly it comes about strutted biplane with uh, half wing. It's a no semi biplane, so called. You see, short low wing and high top wing, but it's not only high. That is decision which is called gull wing. Look at this, seagull wing or gull wing, and what it's for in this case, why they like remove the center wing, why they made V center wing. Pay attention where the pilot is, cockpit is here, and in order to provide visibility of of pilot, ability to see something in flight, they forced to use here the gull wing. No, one more possible decision, of course, to place the wing even lower to this side. No? No, why they broke the wing in this place? What an idiotic decision seems like. But in order to lower the wing, to place it lower, look where it will be. What I'm trying to show you with pointer for you. Somewhere here, in order fighter might see front. Yes, fighter pilot. Yes, but to forgive me, no place here. All airplanes, especially military airplanes, they should be compact. They must be as little as possible. It's the same rule working for another airplanes also. As compact as possible, if only another consideration take place. Compact what for? In order the less compact airplane, the less overall size is, like you less extended on sides, it will be less in weight with respect to the variant which extended. Those airplanes which are for gliding with low wings. In this case, wing is heavier with in comparison with the wing of the same area, but of another shape. The longer wing of the same area, it heavier. What it appeared from why it's like this. It's maybe explain it even for you. You may already understand, but right now just take it as a fact. It's a fact. It's known from statistics and from like history already. Да? That longer wings are heavier, short wings, delta wings, they have less weight, having the same area. And this more compact size demand, it's resulted that you need to use by maximum all the inner volumes, all the inner places of the airplane. It's not possible to place here the wing like this at this place. Why? Wing is not joined to the skin. Wing, uh, longitudinal elements of wing, these spars, they compulsory goes through the fuselage in this place. No, there are decisions where they join it immediately to the fuselage reinforced frames. There are such decisions, but these decisions they are not convenient. They're even more heavy and more simple technically and less in weight will be the airplane where spars from one side and another side they meet with each other somewhere here, or it's immediately meeting of left and right half in structure, or it's so-called center wing, which is actually the same wing, but it's maybe hidden inside the fuselage. It's like a structure of wing, but not visible, let's say, in this case, when it's center wing of the mid plate. No, like it's here, what this bottom wing, they pass through the fuselage and somewhere under the belly they meet these longitudinal elements of this wing. But in this case, they can't be placed lower and in order to meet because here we have engine. Do forgive me, I'm explaining maybe too long and maybe a bit difficult for you. No, you understand, I hope. Why such weird scheme of the wing? They are just not able to pass wing through the fuselage because here is an engine. Why engine is here? Because there is no another place where to place it. Additionally, here it has a piston engine and prop. Additionally, somewhere maybe even immediately under the pilot have to be a fuel tank somewhere here also. Maybe it's under the pilot, maybe it's little far from pilot, but no another place for all these elements. Moreover, take a look. Retractable landing gear. Where this landing gear should be hidden? No, in this photo even visible. Maybe it's difficult to imagine right now. You see, it's hidden immediately in the belly of the fuselage. Even no any additional cowling which protects this place. It just under the belly. Let me to show you maybe in oi. I will not find next anything at all. Кошмар. Sorry. Uh, Ан 140 in flight. In flight, I said. Oh, here is. No, visible for you, I trust. Копіювати. Копіювати зображення. Де-інде. Okay, let it be here. I spoiled this. Spoiled surprise. Sorry. Да увеличься уже, ну, несчастье. Ну. О, look at this. What a gorgeous. It has here additional elements like calling, да, like cheeks on the face of child if you watch it from face. But these cheeks, they to hide the landing gear legs, main landing gear legs. And wheels itself, they are visible. You see, it's complex mechanism of hiding of them, but no, like they are not just move under the belly, but they are visible. And the same we might see in the polycarpov structure. And nose landing gear, you see, it's hidden completely, like in special niche. And that one, it's visible yet by the word. It's with retracted with deviated flaps here, what it's visible, the flap deviated, and aileron in normal positions, what it's visible right now. No, seems like at least they are in normal positions, they are not deviated. And pay attention to the engine. What here is, it's visible that it's a turboprop engine, and those holes under the wings. In cooling, engine is hidden in cooling. Engine is somewhere here, lower than the prop. This pylon, here is the pylon for holding the engine, and this pylon closing, it's like covering engine is lower a bit, and here is we have reducer that which change amount of rotation uh, for engine shaft in order props rotate not so speedy as shaft of engine rotates. And reducer is no, it's like two gears. Of course, it's not two, it's much more complex than just two gears. Now, do imagine here we have one wheel and there we have another wheel. And that is why shaft of engine is approximately here, but shaft of prop is much higher. And additionally, this prop create no, like it's downwash the wing in this place. Of course, you may place it closer, let's say, to the wing, but in this case, maybe it will be worse downwashing, and on some regimes of flight, like this flight controls retracted in the high lift position, it may be resulted in a problem. A lot of interesting things might be said about aerodynamics of airplanes, about the design of airplanes. No, maybe it's a bit earlier for you to overload you with such information whatsoever. Look, retractable landing gear of wheel type here visible, and it's hidden under the belly. And here is full a bomb. You see under the wings, also on special pylons, it has little bombs. So actually it's a fighter, but it has weapon to drop to someone has. Sorry. And the same airplane, swear the same. Sorry, do not swear to anyone. And by the word, here it's visible what is the type of airplane with three landing gears with tail wheel. Landing gear with three legs and tail wheel. Most typical for modern airplane is a nose wheel. But why? No, if we come back to that photo of An-140 passenger aircraft we just have seen, there is a place where to hide landing gear nose in the airplane, inside of airplane. And in those airplanes, which are practically flying engine with cockpit and fuel tank, yes, because they are military airplane, there is no place here where to hide it. It's engine practically. Half of fuselage is engine. And next, as I already said, you cockpit, which is protruding even from the fuselage typically, and fuel tank, and that's it. Here is the whole airplane. What is interesting in this bottom photo, another type of landing gear. You see ski, and the same airplane but with another landing gear on the legs. Now instead of wheels, it's mounted a ski both here and at the tail, because it's more effective to use somewhere with the polar area, in winter airfield even. It will be more effective to use such landing gear, the ends of landing gear like this. Next couple of photo, let's characterize what do we see and how to understand what these airplanes are purposed for. No, quite clear that is business jet by its appearance, and here is so-called general aviation. How do you think which one is more slow? Of course, this one is more slow. Short wing, more typical for speedy airplanes, and this is, I'm not sure. No, I think it's for low speeds like 300s, for instance. This wide span, and once again remind you, it's called aspect ratio. Pay attention. Aspect ratio is span to the chord uh, ratio. And it's like a relative elongation of the wing. Usually in literature it's designated with Greek litera lambda, little lambda, and this relative elongation, the longer the better for in no in meaning of drag. The longer the better because it's minimized drag. For gliders, for aerodynamically perfect for gliding airplanes, longer wing, no, relatively longer wing, like more narrow and long, it's more appropriate, it's more feasible. For higher speed and maneuverability, such wing is more appropriate. It means short wing. That is not much short wing, to be frank. And a relative area of the wing. Now, of course, we see no real size. It's quite clear that this airplane less in sizes than the airplane on the top picture, but relative area. Look, to the cockpit, and considering there are some passengers inside, we see these windows, we understand it comes about passengers inside. No, business jet, it's usually like for from 5 to 10 passengers, not typically. Uh, Flying cap for billionaires, you do remember. And this wing area, certainly with respect to proportionally with respect to the fuselage size, to another sizes of airplane, it's much less. And this wing, with respect to sizes of airplane, is much greater. So area of wing, relative area of wing here, more. And it means that this airplane flies with low speeds. No, as already said, you this aspect ratio also show us, like screaming to us that it's slow airplane. Moreover, here we have a straight wing. It's a bit tapered, but straight wing. And this straight wing, it means that airplane purposed for low speeds. And where you see appeared sweepness and sharpening the nose, it's not for the beauty, it's because of purposes of drag minimization. On the higher speed, it means this airplane in cruise speed flight somewhere near transonic ranges of flight. Not in transonic. Transonic, it's not for flights, actually, you do remember, but close to transonic areas, transonic ranges of Mach number, somewhere 0.8 to 0.9. It's already rather dangerous area, I should say. And that one, maybe couple of hundreds of kilometers per hour. The same as with stabilizer. Look, stabilizer tapered, practically straight, but tapered, so called, because it has axis, this lateral axis, which is not deviated to the back. It's not pulled to the back. It just has different chord in the look at this, in the root and on the tip, but it's straight. It's like line which normal to the fuselage. By the word fuselage itself, look, cockpit and beam. That is how the fuselage. It's like beam-like fuselage here. Practically, it comes about uh, cooling for cockpit, cooling for engine here with prop, you see. What here on the landing gear, what it for? It's like screaming, I'm not retractable, I slow airplane, and these callings are necessary to improve the washing of this wheel and to reduce drag in flight. Drag. And here we see retractable landing gear. If in flight we see no landing gear at all, it means it's hidden somewhere in the fuselage, or it's maybe hidden in other places, not compulsory in the fuselage. It may be in the wing, it may be even in special nacelles on the on the on the wing. Let it be under the wing. We will see it in next photos. What this is? It's what is it? Purpose. Certainly not for civil purposes. And considering the proportion, no, these photos, these airplane proportions, not even sizes, but proportions, what it may be, certainly it's not a fighter. If it's not a fighter, there are two another purposes: bomber or patrolling reconnaissance airplane. No, I know very well what is it. It's strategic bomber, so-called strategic bomber of new generation. Not new, because when I was a child, they already exist. It's so-called White Swan. It's Tupolev 160, and very similar in design, in appearance, airplane. It's American Lancaster B1. I'll show you, but again, I'll spoil it surprise. You will not see. You will see some photos which related to your practical tasks. It's not finished because it's like collection of photo here. What look barely distinguishable, to be frank. No? Where we have this Lancaster and where we have Tupolev airplane. I mean Tupolev White Swan. In NATO classification, it has some another name. White Swan is translation of our name for this airplane. Because while takeoff, it's really looks like. I hope you understand my pronunciation. I will do it right now here. Oh, and this airplane is extremely elegant during takeoff and very similar to takeoff for this bird. Oh, something like this. Looks like certainly not like this. I can't find the appropriate photo. Sorry. No, you understand what do I mean. While takeoff, usually they open wings widely, and looks it's very beautiful. That one it's some dreadful thing. Airplanes does not take off like this. Never. Only in airfield position, maybe in such a way. Let's come back to our stories. Gentlemen, what do I see? I see that time should be stopped. Let me to stop, make a pause, and next I will continue explanation. I'll interrupt the record for some seconds.